At the bottom of the world, the melting of Antarctica is speeding up, and scientists are paying close attention.
Antarctica holds almost all of the ice on the planet. The glaciers are rivers spilling off the ice sheet, bringing ice to the ocean. The ice shelves act like a dam, holding that ice back to an extent.
But when these ice shelves disintegrate, the glaciers have nothing to stop them. West Antarctica is melting faster and contains enough ice to raise the sea level by 14 feet. East Antarctica is also showing signs of melting and holds enough ice to raise the level by 175 feet. Current predictions suggest a sea level rise of 3.5 feet by 2100. The question now is, how is it happening?
As the ice hits the ocean, it begins to melt and it floats to form an ice shelf. And our evidence tells us that over time, this amount of melt has increased and caused more melting where the ice lifts off from the ground and becomes a floating ice shelf. We call that the grounding line. So as warm water spills in underneath the ice shelf, it goes all the way to what we call the soft underbelly, which is where the ice lifts from the base of the ocean floor at the grounding line, causing melting. And that seems to have increased over time. And that's what we've seen at the Pine Island Glacier, is that the ice shelf is becoming thinner because of ocean warming, and the glacier stresses working on the ice shelf are overcoming the strength of the ice shelf, causing it to crack and break apart more quickly. When you suddenly take away the ice shelf, you cause the ice to accelerate, like opening up a floodgate on a dam, and you let the ice spill out. So when we ask the question of how quickly can we lose ice, it hinges on how quickly can the glaciers accelerate due to loss of the ice shelves that are holding them back right now.
The Totten Glacier is larger than California and is also losing ice, melting from above and dissolving from below. Elsewhere on the continent, warm wind flows down the glacier and exposes darker ice. The dark ice absorbs heat and melts faster. The meltwater then collects in subsurface lakes and flowing streams.
Glaciologists have a lot of work to do in sorting out what is a normal process and what is a harbinger of accelerated collapse.
Ice is constantly on the move in Antarctica, moving faster at its ice shelves and glaciers along the coast.
Antarctica is unique in that it could cause a change that civilization hasn't ever experienced. It threatens millions and millions of people. The shorelines that will be affected are global and they're heavily populated. Can you have complex civilization like we have when you have a rapidly disintegrating large ice sheet? That is the question. So that's why everybody needs to be concerned about what's going on in Antarctica.